Hello again and welcome to week 7. This week I want to talk a little bit about the teaching of geometry and measurement, and then at the end I just want to spend a little bit of time talking about planning. Now I know you've probably done planning in a lot of your other courses and your general courses, so I don't want to repeat all that, but I just want to give you a few practical tips that might help, particularly as you think about planning, learning and teaching in mathematics. Also here I'm going to give you hopefully a range of practical ideas, not that these are necessary things you can just copy and use straight out, but to give you ideas of how you might do these things with your students. In the junior secondary part, a lot of this work around geometry is around trigonometry and Pythagoras and things like that, and I've asked your tutors to focus on that specifically this week. So things like geometry and measurement should always be pretty practical. Geometry is about shape and space and moving through space and understanding space. And so therefore it's important that kids actually get to move around and experience it. It's very difficult to do that just from a textbook. And it's something that you could hopefully find all around them in things they might do and experience just in their life outside of school. So these are just some ideas, things that have worked in other places and some that are pretty average, but just to give you some tips about what you might see and experience and how you could perhaps modify them. So one of the things we commonly used to do was about building a house. And one of the schools I worked at, we had a new subdivision right behind the school, so we talked to the developers and asked if they could give us some of their plans and ideas, and we also got them to come and talk to the students. So the idea was you've got a new block of land and you're going to build a new house, and the task is to develop a scale diagram of the site boundaries, and we could give them some of the council regulations around what they had to have. Considerations like you didn't want it to be just all like a series of boxes and square things. How could you make it interesting, including parks and things like that? You need to find a house plan that would suit your site, and these are readily available from any of the building companies. And they had to consider things like how close they could put it to the boundary, etc. Then they needed to draw a plan of the block to scale and including the house, outbuildings and landscaping. And then if you wanted to, you could include options like financing it, etc. So there's lots of options to do things about geometry and measurement, the angles, those sorts of things, the area, the space required. But there's lots of numeracy as well about percentages of the land that has to be unbuilt on and the amount of land that has to be in park space, that sort of thing. So it's just really a practical idea that you could modify to suit if it was of interest to the kids where you were working in. I did do it regularly in one school where we had a new subdivision at the back. I tried it in another school and it fell pretty flat because the kids just thought, well, we're never going to build or buy a house. So a lot of them weren't greatly interested in the topic. But it's a way of putting something practical around it. Another thing we often do with geometry is we use diagrams and pictures. And so these next couple of slides are really just about saying, be really careful about how you draw it and what it looks like. And also make sure you give the students a range of representation. So don't just draw it from one perspective all the time. So maybe show them, in this case, a tetrahedron from 4 or 5 different perspectives. Maybe give them a real one and get them to move it around and see it in different ways and what it might look like. Things like a pyramid, if you draw it upside down, they don't think it's a pyramid anymore. But there's no such thing as an upside down pyramid unless you're an Egyptian building a temple for some pharaoh that's passed away. But playing with 3D shapes, and it's very difficult to do 3D shapes in a textbook because it's flat. So the picture there, the interesting thing with this one is different people see different things. Is it a triangular base pyramid? Or is it a square-based pyramid looking from the top, right on top of it? So it could be the same thing. So I've seen pictures like this in books and even in exams and things, and students have got it wrong simply because the diagram was misleading or could be understood in different ways. So be really careful with your diagrams. Try not to necessarily just draw them off the top of your head, because unless you're really good with your figures and on a whiteboard and things like that. But the diagrams are really important in measurement and geometry, particularly for visualizing things, because often they'll look at the diagram and see different things. That one there is just an example. Here's some other examples. These are copied straight out of a textbook. What's better about these? How are they better? What do you see when you see them? Again, the point here is just you need to be really careful about your diagrams, because they can be interpreted in a range of different ways. And here's some other ones. Again, these are straight out of a textbook. So when you look at it, you probably see something. You probably see what you expect to see and what you plan to see. But particularly if you're drawing diagrams, often they can be misinterpreted a range of ways. The only reason I put this in is because in geometry and measurement we use diagrams a lot. And the problem is we're representing a three-dimensional object in two-dimensional space. Incidentally, often the students are really good at understanding three-dimensional space represented two-dimensionally, because they play so many computer games where they're moving through representations of three-dimensional space on a flat screen. At least people my age are not very good at that. Here's another sort of question we often get, and this is one that's often used with Pythagoras. You know, you've got a box. What's the longest straw you can fit in the box? Now again, in my opinion, this is not a very interesting question at all, and most kids just see it as an exercise, even though it's often proposed as some sort of practical application. Why would anyone put one straw in a box? I've seen it done other ways, like someone's trying to smuggle a file into prison to get their mate out, and so they've baked a cake in a rectangular cake. What's the longest file they can fit in? So you can try and fiddle around with those sorts of things, and maybe they'll be of interest to students, but you need to just really decide when you meet your students and work with them. But the point is here again is it's a diagram to try and represent a three-dimensional shape, to try and get students to do Pythagoras. And the diagram may or may not be helpful, but it's just the sort of practical example we see that could often be done so much better if we were given something that connected with the kids more realistically. You can see these sorts of ones. The problem we often have is this question comes after we've given the students 100 Pythagoras questions to try, and then this is number 101. And we expect that they can transfer what they've learned from the first part over into the next part. And often the problem they'll have, particularly if the diagram is not provided, is one, they need to learn to draw some sort of diagram, and then to see that in this case, it's a two-step Pythagoras problem. So you need to use Pythagoras to find that diagonal line across the bottom, then use that answer to try and work out the length of the straw, as interesting as that might be. So making the connection between those exercises to these sort of applied problems is really important, and don't assume the students would just be able to do it automatically. This is something you have to teach them. Some other things you can do is earth geometry, and to do this, I've tried it with balloons. The problem is often the kids pop them and they're not often spherical. Styrofoam balls work quite well. They're easy to cut and that sort of thing, but they do make a mess. But again, there's part of the curriculum was always about time zones and distances across the planet and all those sorts of things and directions. And this is all three-dimensional around a sphere. So I think it's very difficult to do if the students aren't experiencing some sort of spherical object in three-dimensional space to try and understand it. It's very difficult to draw in a flat way. And even now you can get some apps and some electronic models to use, and they're okay, but I would always start with something the kids can hold. And again, styrofoam balls were good, but when I did get them to cut them, remember they did make a mess, and sometimes it's not a good idea to give kids knives in class. But there's some questions there you could ask them around them about flight paths. Why do they go certain ways? You know, and at the moment, obviously, some of the reasons might be if you're flying to Europe, you don't want to fly over the Ukraine, etc., etc. Some of the interesting ones for them to possibly consider is if you're flying from Australia to London, for example, is it quick? We always go one way around, which is through Dubai or something like that. But what if you went, so that's going west, but what if you went east? Would that be quicker, or why not? Again, house plans are something that's quite practical, although may not be of interest to the kids, but there's lots of measurement, practical measurement and geometry involved there. Designing a kitchen, painting the walls, how much paint do you need, how much is the coverage of the paint, that sort of stuff. Lots of things you can do there, and you can make it as complicated or as simple as you like. The roof trusses are interesting because it can involve Pythagoras and even trigonometry if you want to get a bit fancy. And again, this is another way, finding areas, interpreting maps of unusual shapes. So we spend a lot of time with kids learning to find the area of regular shapes, but in real life there's very few times that you need a regular shape. Often it's some unusual shape. So getting the kids to work with these, and I would start with these problems and then try and develop the mathematical concepts from it. Again, this is not rocket science, just trying to give you some practical things that might be worthwhile trying with your classes. Interpreting maps, often a way of doing this is doing orienteering with the kids, getting them to do orienteering and finding things around the place. A challenge sometimes is having the kids running all around the school or the field in different ways. But if you can do this in a practical way, where management is okay, then it's a perfect place to understand about bearings and measurements, angles, distances, scales on maps and those sorts of things. And in this case, from the picture you can see there, the contour lines. What does that mean? Why would you take that line through the middle there as opposed to going a bit lower? Also some surveying techniques. Sometimes you need to find certain distances, but you can't obviously walk it with a measuring wheel or anything like that. So how can you do it in another way? One of the things we used to do with our students is take them on a maths field trip. So they did field trips for science, they did field trips for social studies, they did field trips for everything else, and they never did one for maths. So we used to take them on a field trip to a park on the edge of the forestry area, not far from the school, and the kids did a range of activities, mostly involving trigonometry, Pythagoras, and part of it was finding the distance across a lake in an example a bit like this. Another one was there was a forestry, a timber forestry right next door, and the question was, what's the volume of the tree, when should you cut it down? And they had to find out how high it was by using various measurements. Hopefully it was sunny, there was some shadows and things like that. Also, there's lots of things you can do now with technology. Google Earth gives you pictures from above, and particularly one time we worked in an Aboriginal community in the Kimberley, and it was interesting. These students had never been up in a plane or anything like that, and we showed them images of their community and their surrounding areas on Google Earth, and they could really readily identify things and work through that space. So by having that bird's eye view of a community or a space was an interesting way to then try and locate places, try and work out distances, and try and connect their practical knowledge to what the image was showing, that sort of stuff. So there's a lot of practical applications and those sorts of things. And there's some other ideas there, investigating effective packaging, etc., etc. So that's just a few practical ideas about geometry and measurement. And like I said, in your tutorial, your tutors will cover something around right angle triangles in practical ways. The other thing I just wanted to talk briefly about was planning. Now, in a lot of courses, you'll get asked to plan a unit of work. We haven't done that in this one because we figured you've probably done it quite a lot already. It doesn't mean it's not important, but one of the things you'll do, particularly as a student teacher and when you become a first and second year teacher, is a lot of planning, because you can't fall back on what you've done before because you haven't done it before. So how can you do a planning that's not a waste of time just to fill out some forms to keep someone else happy, but that's actually useful? So why plan? Well, it's important that you've got some relevant experiences, and it helps you to think about different ways of doing things. If you don't plan, what you'll tend to do is exactly what was done to you, and you just do it off the top of your head. And even though you're probably not that old like me, the students are still different from you, and you need to try and connect to something that helps them to learn it rather than necessarily just how you were taught previously. Planning also helps you focus on the important things, and it helps you sort of keep on track for time. It also, in planning, means you will cater for a diverse range of students. So one of the things that tends to happen in maths is we tend to teach straight down the middle, and we lose the kids who are struggling a bit, and the kids who are a bit advanced get a bit bored. It's really not good enough as a teacher to do that. You need to make sure you cater for all the kids in your class. Those who might be catching up a little bit, those who are already ahead and need something to stretch them a little bit. You need to have a range of activities. You can't just have one with no modifications for those students who have different needs at the time. And also in your planning, what's important is you cover the affective aspects. In other words, in your planning, think about how can I help the kids generate an interest here? How can I make sure they are enjoying what they're doing and finding it useful? How can I ensure that they understand that this is not just some dry, boring stuff they have to learn for a test and then they can forget it, but it's actually stuff that people use in real life? If we fail to address the affective part of learning maths, then by default you will teach kids to hate math, that it's irrelevant, and then they should avoid it for the rest of their life if they can. That's mostly what I taught my kids. It was never part of my plan, but because I never planned to deal with it directly and overtly, that's what happened. I think that's really important. This may or may not be helpful for you when you're doing some planning. I sort of have some sort of cycle. It's got 3 parts in it, and you've got to consider the mathematics you want the kids to learn. And by that, I just don't mean the dry content, but how do you want them to understand it? If they're doing something like percentages, how can they see percentages as something that's used by a lot of people in society? How can they certainly understand the knowledge, but also how can they learn the skills that might be relevant to them? The second part is the pedagogy. How are you going to get the kids to learn it? How will you help them to understand it? What activities will you do? And then the third part is the students themselves, because students are different. If you're teaching at, say, TSS here on the Gold Coast, you might teach the students there will be quite different than if you're teaching, say, at Mount Isa Primary School. So how would you teach them in different ways? How are you going to cater for them? Because when you plan, what you need to be doing is taking them from where they are and helping them to move forward. Now, if you want to see that diagram in more detail, including these lists, all these slides are on the Learning at Griffith site. So an overview, if I was planning a unit of work, and normally what we want to do, when you start, you'll plan lessons, but as you move on in your career, even as a student teacher, you don't want to plan lesson. You want to plan the whole sequence of things over 2 or 3 or 4 weeks. So what we call a unit of work. And you've got to think, what are the things we want to achieve over this period of time? And that would obviously be develop knowledge and understanding and skills in those things, but also those affective things. What do we want them to develop about those things? How can you work out what these are? Well, you probably have to start with the curriculum document and see what's being covered there, but also look through textbooks. Not that you necessarily have to follow the textbook. In fact, I hope you don't just follow the textbook, but it does give you a sequence of ideas. And you might say, look, for this part, I'm going to use the textbook activity. For this part, I'm going to take the textbook activity, but I'm going to change it and get it as a group activity where the student's going to do. And then you might also look at all sorts of other resources. When you're in a school, you'll go to the maths resource room and there'll be a whole pile of books in there that you could use. And then of course, you just have to go online and there'll be a million resources you could find. Incidentally, if you find these resources, make sure you try them out first and then modify them to suit your situation. So I've been in a class here in Australia and the activity talks about students measuring things in feet and inches and yards because they took it straight from America. And of course we don't use those, we use the metric system. So in that case, the activity was fine, but you have to transfer it to the context where you're working. I think it's important to talk to other teachers, get their ideas. They've got a lot of experience, they'll know the students in your school. Particularly as a student teacher, I'd ask my mentor teacher how they might go about it. and try it out. You've got nothing to lose, because after a few weeks you move on and you won't hurt the kids. Make sure you're working towards developing understanding. You know, in the last few weeks we've talked about start with conceptual development before you then go on and do the practice to make it automatic. And then I'd develop a rough outline of ideas or experiences just on a piece of paper. I used to do it a bit like a concept map or something like that. And then I'd try and turn it into a sequence of lessons after that. So here are the 4 key questions when you're doing planning. The first question I always used to ask when I had student teachers as a teacher, these are the 4 questions I'd get them to do. First question, what do you want the students to learn? And by that, I do mean content and things like that, but also those other affective things we've already talked about. The second question, why do you want them to learn them? And it's not good enough just to say it's in the curriculum. There must be reasons for learning stuff. And I'd investigate those. Sometimes I had to look it up. Why would anyone learn calculus? They shouldn't be learning calculus in the junior secondary, but if I could give my students an answer, they were much more interested in learning it. The third question, how would you know when they've learned something? So that's about assessment. Okay, so if you've taught students something, how do you know that they've learned it? And finally, how can we best help them learn? That's the activities and the experiences you're going to develop for them to do it. So things to consider, the first one, what do you want the students to learn? The official syllabus, the school will have a program, but also the students that you're teaching, the school context, and how much time you've got available. All those things will impact on what you want the students to learn. So you might be doing something about area, and you might want the students to learn all these things about area, how useful it is, and take them on excursions and try stuff, but you might only have 1 week to do it. So therefore that might limit what you can possibly do. Second question, why do you want them to learn? Why do you want the students to learn it? This is really important. It's something we rarely do. How will they apply this learning to real life context? How does this link to the other learning in maths or other areas? So for example, if you're teaching them about trigonometry, they should understand that it's related to Pythagoras. Or when you teach them the sine and the cosine rule, they still understand that that doesn't wipe out all the other stuff they've done using sine, cosine and tan. It all builds together and it's all connected. So they get a robust knowledge, not these silos of things that they think have got nothing to do with each other. But really important, I would hopefully see everyone asking the question, why should the students learn this before they plough into some sort of unit of work? The third part is the assessment, if you like. And rather than saying, how will you know when the students have learned, what I would prefer you ask is, how will I know what the students have learned? Because we often make the assumption that what we teach students is what they learned. And sometimes they learn something a bit different. Sometimes the way we've presented it might be okay, but the way they've perceived it is different. So I'm always trying to find out what the students have learned, because sometimes I've unintentionally led them a different way. So that's why having assessment, which is open-ended, remember in the first task we asked you to use open-ended tasks to find out what they've learned rather than to find out if they've learned what I've taught them, if that makes sense. And that's what I mean by having an authentic assessment task that directly assess the outcomes. So in other words, if you've done measurement in a very practical way, then make sure the assessment you do reflects the style of learning that you've done. The last part, and probably the bit we focus on the most, in fact sometimes we go straight here, how can I best help them learn? Now it's really important that when you develop a learning sequence, it starts where the students are at now. It's no point just going straight down the middle and ignoring what they already know. So if they already know some things, you can very quickly go through some stuff and catch them up on it and then move on. But if they've got some gaps, the first thing you're going to have to do is fill those gaps. Now sometimes you might get students who might be what you consider a year or even 2 years behind in some areas. They might have been sick for a couple of weeks or something and missed a part of their learning the year before. So what I used to try and do is give them some just-in-time learning. So for example, if you're doing trigonometry, they're going to have to work a little bit with fractions. And sometimes the students come to do trigonometry, they can learn the trigonometry, but they can't remember the stuff we did with fractions. So I might just give them a little bit of a catch up just in time learning about fractions. So I don't cover the whole 2 years that they've missed, but I just cover that bit to help them catch up so they can then move on from where they're at. But it's important that you really take the students from where they are and help them move forward. It's also important, as we mentioned before, that you provide for a range of abilities and personalities and interests. So one of the things, mistakes I used to always make, I was always interested in sports. So whenever I had a context for anything, it was almost always sport. And the kids that liked sport really loved it and really connected to it. But there were some kids who really weren't into sport and they tended to get bored, and they, in the end, asked me if I could do something other than just sport examples and applications all the time. But that's the part we really focus on, what we're actually going to do in the classroom with the kids. So how can you develop these different learning and teaching activities? Well, I'd just collect as many resources, and particularly now as you go through your undergraduate degree, just collect them and keep them either electronically or in physical form, copies of all sorts of resources, because you don't know what you're going to need when you go out. Now, textbooks, again, I've mentioned textbooks before. Textbooks are useful. I hope that's not your whole program, is just working through a textbook, but sometimes it's useful to pull an activity out of a textbook. Sometimes you'll get the kids to do an activity out of a textbook, but if you're doing that more than 25% of the time, I dare say your program's lacking a bit of variety. But sometimes I'd see a good activity in a textbook, but rather than giving it to them in the textbook, I'd take it and make it into a class activity and do it together. Obviously the internet's got piles of resources and there's lots and lots of resource books available. Syllabus documents often have ideas and things you could use, but the other place is just getting stuff off each other. So soon you're going to go and prac and you'll try stuff out. Well, if you see something good, see if you can grab a copy of it, either a digital copy or a physical copy, and when you come back, you can share them with each other. The richer supply of resources you have as you begin your teaching career, the more helpful it can be. All right, one last thing, concluding comments, and you might recognize these from last week, but I'm going to say the same thing again. What's really important is, after building conceptual understanding through activities that connect with the students, then you build automaticity through purposeful practice. That's when you do the textbook activities in a more generalized, abstract form once they understand what they're doing. There's no point practicing something to get kids to be able to do it if they don't understand what they're doing. The second thing is, make sure you connect your formal assessment requirements as you go through. And I mentioned this last time. If I was doing some activities on Pythagoras, for example, then I would start with some hands-on practical things. I might have the kids outside measuring space and things and try and work out Pythagoras in space by moving around and touching stuff, or I might have some ropes or whatever, all sorts of things, activities. I'll do that first. And then from that, I'll try and generalize to get the idea of Pythagoras' theorem. I wouldn't start by saying, this is Pythagoras' theorem and let's apply it. I'd try and get them to see it from a practical sense and build up a conceptual understanding first. Then I'd try and generalize so they can see it in an abstract form. A squared equals b squared plus c squared. And then once I've done that, I'd then try and get them to use that through purposeful practice in ways where they don't have to keep going back to the practical example. But I'd get them confident in doing those sorts of things, and then I would connect to the understanding so they could sustain it and use it elsewhere. Anyway, that's